Hi there, just wanted to show you the new Growatt SPA range. This client had a AC coupled inverter to go alongside his existing SolarEdge system. Because SolarEdge works on micro optimization, they can't have a DC coupled or hybrid solution battery store just because of having no high voltage PV voltage coming from the roof itself. What we do in this instance, we'd have an AC coupled solution that operates on two CT clamps. One monitors solar production and one monitors load consumption. We'd strap in a separate inverter, which is the SPA 3000 in this instance. What happens is basically this can operate on multiple generating sets. So if you've got 2, 3, 4 inverters, this AC coupled solution will monitor the aggregation from every one of those particular inverters. It's a perfect opportunity to use it on wind turbines or PV. The system itself at the moment is obviously charging the batteries up because we've got an abundance of surplus electricity coming from the solar panels. So CT clamp 1 monitors load consumption of the property itself. So if it's using 600 watts, what it does, that information gets put through to the unit itself, and then it gets shown on the actual menu itself on the displays. CT2 monitors solar production. So if you've got 1 or 2 inverters and the collective is generating 3 kilowatts, for instance, what happens is CT2 picks up on that additional current flow and then charges the batteries up based on the actual output current. So PM on the screen itself is power management, so that's the difference between all three, and then PEX is the power external generation. So the SolarEdge inverter that's up in the client's roof at the moment is obviously sending 740 watts back towards the battery itself, and the property load is only 520. So in essence, they're not using any grid power. The battery's charging up by the difference in demand. So what will happen is basically the batteries themselves will charge up. You'll see the green lights flashing on the units themselves, and then as soon as the batteries get full capacity, they sit in hibernation until the property needs it late in the evening. With this particular model as well, it has got EPS functionality, so in the event of grid failure, you can have it as a direct form connection to obviously a twin socket. So at the moment, the water pump is not on. We've got a vacuum and one other socket running on there. So basically, in the event of power failure, the client's got access to 2 points of 230 volt supply coming from the EPS. When EPS is active, batteries step in and intervene, and it comes down for the overload protection. It tells you your battery's voltage and charge percentage, and also it'll tell you exactly what's going out to the battery itself. So it is a little bit more reassuring having some point of an emergency power supply for the sake of power outage. You can't have this EPS connected back to the main distribution board, simply because in the event of grid failure, you have to create an island revoking the use from the supply itself. If this was fed straight back into the existing consumer unit itself, obviously it'd send voltage back out onto the main line and electrocute whoever's working on the supply itself. So, but from a basic fundamental principle, this will store the energy, charge it up and discharge it dependent on what the property is using, trying to keep the property net zero for as long as physically possible, as long as there's capacity in the battery itself. Just wanted to give you a brief overview of obviously what the type of systems that we can do and how this system particularly operates. Okay, speak soon, take care.